Merhaba. Şu an nerede kalmıştık en son? Getters and Setters'da kaldık. Ben havlu atmıştım. Çünkü kafam almazdı. O saatte uykum vardı. Çok erken uyanmıştım. Saat kaç gibi uyandım? Bayağı erken uyandım ya. Sonra gittim biraz daha uyudum. Bir şeyler izledim, bir şeyler okudum. Şimdi tekrar işimizin başına döndük. Yapmamız gerekenler neler var? İlk önce bu videoda ilerleyebildiğimiz kadar ilerleyelim bakalım nereye kadar kafam alacak ondan emin değilim. İkincisi biz ne demiştik? 5. video Dictionaries'i bir bak demişiz. Dictionaries kullanımını Python'da çok bilmiyorum. Yani bildiğim sintaksını çok az biliyorum. Onu biraz öğrenmek istiyorum. İkinci videoyu izleyip orada da izleyeceğimiz şeyler varmış. 6. videoda try and accept yapısı varmış. Onu izleyecekmişim. Sonra bir de bu kaçıncı? 14. video API ile alakalı bir şey varmış. Onu da izleyecekmişim. Bu videonun bitmesine yaklaşık 1 saat 30 dakika falan var beyler. Aynen. 1 saat, 1,5 saat işte. 1,5 saatte bu videoyu izler miyim hepsini? Emin değilim. Kafamın ne kadar aldığına bağlı. Belki işte son inheritance yapılarını falan bırakırım. Belli olmaz. O anki şeyime göre değişir. Ama bu sanki 5. video ve diğer şeyler başka bir zamana kaldı gibi. Çünkü ana hedefim bunu mu yapsam yoksa diğerlerini mi denesem bilmiyorum. Saat 1'de, 1.30'da da başka bir toplantıda olmam lazım. Bakalım. Devam edelim.
Dating name and house, making sure that name is not blank, and making sure that house is a valid house among those 4 Hogwarts houses. It turns out that classes will still let me get at those attributes, those so-called instance variables, using dot notation anyway. Let me scroll down then and try to do this a little adversarially. Suppose that on line 16, I go ahead and call get student, which exists as before, and then I store the return value in a student variable, again on line 16. That will ensure that get student gets called, which calls input, and then it calls the student constructor, which invokes automatically this init method. So by way of how we've laid out my code, we're going to ensure that name is not blank, and house is definitely one of those 4 values. My error correction or error checking is in place. But if I'm a little adversarial, I can still circumvent it. Suppose that, fine, you're gonna require me to type in Harry and Gryffindor. I'm gonna go ahead and type in student.house equals quote unquote number 4 privet drive, and you're not gonna be able to stop me. Why? Well, it turns out with classes and objects thereof, you and I can still access those instance variables using this familiar dot notation. That's how we began the story of classes, just setting these attributes ourselves, but you can also read these attributes themselves and change them later if you want. And this will effectively circumvent the if condition and the other if condition in our init method, because that is only called when you first create the student object. There's nothing stopping me at the moment from just changing the house or the name after. So if I now clear my terminal window and run Python of student.py, I'll still type in Harry and Gryffindor to meet my requirements that the house be one of those 4, but when it's printed, notice, I've still overridden it. So it seems that while classes do allow us a little more control over the data we're storing, it doesn't necessarily prevent the user, or rather the programmer, be it myself or maybe a colleague, from still kind of messing things up. So here too, in the spirit of programming a little more defensively, allow me to introduce another feature of Python as well, namely properties. So a property is really just an attribute that has even more defense mechanisms put into place, a little more functionality implemented by you to prevent programmers like me and you from messing things up like these attributes. So again, a property is going to be an attribute that you and I just have more control over. How? We just write a little more code using some Python conventions. And how we're going to do that is going to use in just a moment a keyword known as @property which is technically a function. Property is a function in Python, but we're about to see some new syntax that allows you to decorate functions. And this too is a term of art. In the world of Python, you can have decorators, which are functions that modify the behavior of other functions, if you will. And we'll leave it at that without going too much into the weeds, and we'll see by example how you can use these decorators specifically to define properties. So let me go back to VS Code here, and let me propose that I do this. I'm going to go ahead and create, how about, a property called house as follows. Inside of my student class, I'm going to go ahead and below my init method and below my stir method, I'm going to go ahead and define a function called house that takes, as it always must, one argument at least called self. And what I'm going to do now is return self.house. So I'm just going to define a method called house whose sole purpose in life is to return the value of house. But I'm going to define one other method, curiously also called house, but that's going to take into as arguments two values, self, as always, and also a value called house. And I'm going to now do this. I'm going to say I'm going to do self.house equals house. Now, what have I done? Well, let me just temporarily add some comments here. In a moment, we're going to start referring to this generally as a getter. And down here, I'm going to refer to this as a setter. And this is terminology you frequently see in the world of Java. Some of you have programmed in Java before. But as the names imply, a getter is a function for a class that gets some attribute. A setter is a function in some class that sets some value. And now, even though we're not done, and there's a bit of a mistake in the code I've already written, intuitively what we're going to do is this. We're trying to prevent programmers, myself included, from circumventing my error checking that I put into place for name and house. How can I do that? Well, we don't have that many building blocks in programming. We've had things like variables for data, and we have functions for actions. Well, why don't we do this? Why don't we somehow require that in order to access an attribute, you go through some function? And let's require that in order to set some attribute, you go through some function. And conventionally, those functions are called a getter function and a set and wire. In
Bir
some
dakika,
class,
böyle tekrar dinleyeceğim.
say I'm going to do self.house equals house. Now, what have I done? Well, let me just temporarily add some comments here. In a moment, we're going to start referring to this generally as a getter, and down here, I'm going to refer to this as a setter. And this is terminology you frequently see in the world of Java. Some of you have programmed in Java before. But as the names imply, a getter is a function for a class that gets some attribute. A setter is a function in some class that sets some value. And now, even though we're not done, and there's a bit of a mistake in the code I've already written, intuitively what we're going to do is this. We're trying to prevent programmers, myself included, from circumventing my error checking that I put into place for name and house. How can I do that? Well, we don't have that many building blocks in programming. We've had things like variables for data, and we have functions for actions. Well, why don't we do this? Why don't we somehow require that in order to access an attribute, you go through some function? And let's require that in order to set some attribute, you go through some function. And conventionally, those functions are called a getter function and a setter function. And why are we using functions, or in this case methods, inside of a class? Well, once you have functions, those are just actions or verbs that you and I can create ourselves. We can put any error correction I want in these functions because it's code that's going to get executed top to bottom. So how can I now prevent the user from setting the house to an invalid value? Let me borrow some logic from before. Rather than blindly do this, just set self.house equal to the house value that's passed in. Let's add our error checking there.
Burada o kadar fazla house oldu ki hangi house'u neye eşitliyor şu an ben
So
kaçırdım
if
yani.
house is not in the following list of Gryffindor or Hufflepuff or Slytherin or Ravenclaw or Slytherin, just as before, let's go ahead and raise a value error just to signify that something has gone wrong. I'll be more explicit. I'll include a message like invalid house, quote unquote. Otherwise, I'm going to proceed on now line 21, to set self.house to house. So I've just copied, if you will, or retyped my error checking inside of this so-called setter function. Now, why have I done that? Well, to be clear, whenever the user or the programmer writes code like this, student.house equals, what's about to happen magically is Python will not just let the programmer access student.house directly, that attribute, that instance variable, aka self.house, it's instead going to magically, automatically call this setter function for me. How does Python know to do that? Well, if it sees that on the left-hand side there is self.house, where house is the name of the getter or setter, and then it sees an equal sign indicating assignment, that's just enough of a visual clue to say, wait a minute, I'm not going to let you access that attribute directly. I'm going to use the setter instead. Why? Because the equal sign means I'm trying to set, I'm trying to assign a value from right to left into that attribute. So what Python's going to do automatically is call this function for me. And that's amazing, because now I can execute code, an algorithm, to check, do I want to let the user, the programmer, set that attribute to that value? If not, I'm going to raise a value error, and you're just not going to be able to do it. If so, fine, I'll go ahead and set it for you. But in order to do this, we need a little more syntax, and I'm going to get rid of my comments, and I'm going to use that decorator. I need to tell Python to treat this method as a getter, and then the syntax for the setter is a little different. You now say house.setter. I wish one was getter and the other was setter. That's not the way they designed it. When you want to define a getter, you just say at property above the function. And you name the function exactly like you would like the property to be called, quote unquote house. Once you do that, you can now use a new decorator that's sort of automatically created for you called @house, because I called it house. And then you literally say @house.setter. And this whole line on line 17 is a clue to Python that here comes a function whose name is identical, but notice that it takes two arguments, both self, so you have access to the contents of the object, and house, which is just going to be a stir that comes from the programmer, from like the human input return value, so that you can set that value as well. But there's one fix I need to make now here. Everything else I think is still good. However, watch this. I no longer need this error check here. Why? Because if I scroll back down to my code here, I claimed a moment ago that code like this with student.house equals is going to automatically get Python to call my setter for me. Guess what? Even up here in my init method, calling self.house equals is also going to call my setter method, which is amazing because now I can keep all of my error checking in one place in the setter. And it will now get called either when I create the object for the first time because of init, or even if the programmer tries to circumvent that init method and change the value of this attribute, my setter will also get called. My setter will get called anytime I access .house. But there's one fix I need to make. Unfortunately, I have collided names. Right now, if we go up here on line 5, this is an instance variable. It's a string inside of myself, inside of the current student object called name, and this is another instance variable called house. Unfortunately, if I have an instance variable called name and house, I cannot also have functions called house. They're going to collide. You got to decide, do you want the variable to be called house, or do you want the function to be called house? Unfortunately, you can't have both, because now Python's going to confuse one for the other. So the conventional fix for this is to do this, to have the setter not store the value that's passed in self.house, but to use an almost identical name, but to use a little indicator that means you know you're doing this correctly. You typically, by convention, put an underscore in front of the instance variable's name. And when you return it up here, you similarly put an underscore. So now technically, my instance variable is called underscore house, but my property, which is a fancier attribute, if you will, is called house alone. Huge amount of syntax, I know, but it's a very powerful feature. And again, This is why you can graduate from dictionaries alone and have so much more functionality at your disposal. Let me go ahead and clear my terminal window and run python of student.py, enter. Name, all right, let's go ahead and type in Harry. Let's go ahead and type in Gryffindor, crossing my fingers as always, and now look, invalid house. This is a good thing. Why? Because notice, in my main function, I'm still trying, maliciously if you will, to change Harry's house to not be one of the 4 valid ones. I'm trying to change it to his childhood home of number 4 Privet Drive. But because Python knows that, wait a minute, you're trying to assign, that is set a value, and that value, aka house, is now defined as a property, you're going to have to go through the setter function instead to even let you change that value. And because I have this raise value error if the house is not as intended, you're not going to be allowed to change it to an invalid value. So I'm protecting the data on the way in through the init method, and I'm even defending the data if you try to override it there. So I think the only solution for me, the programmer, is don't try to break my own code. Let me remove that line because it's just not going to work. Let me run python of student.py, and again type in Harry, type in Gryffindor, enter, and Harry's indeed from Gryffindor. If I did something incorrect, like Harry from number 4 Privet Drive, enter, we're again going to see the value error because my code just doesn't let that value in via manual input now or via that adversarial change. All right, that was a lot, but any question on properties?
While we are using getters and setters, it's just for the purpose so that we can find that function, that method.
Ya kısacası diyor ki getter ve setter'ları niye kullandık? Getter ve setter'ları şunun için kullandık. Değişmesini istemiyorsak kullanıyoruz işte. Yani biraz daha şey olacak. İşte dışarıdan erişilemeyecek.
That function in our code.
The reason that I'm going through the trouble of defining this getter or setter is because I want to make sure that programmers cannot do things like this. If I'm going through the trouble of validating the attributes for these student objects, I don't want you to be able to go in there and just change them at will. I want to have some control over that object so that you can just trust that it's going to be correct as designed. So using a getter and setter really just enables Python to automatically detect when you're trying to manually set a value. The equal sign and the dot, as I've highlighted here, is enough of a clue to Python to realize, wait a minute, you're trying to set a value. Let me see if this class has a setter defined, and if so, I'm going to call that, and I'm not just going to blindly assign the value from right to left. So it's just giving me more control. Other questions on properties?
When we use getters, we just have just one argument. And if we use setters, it's always going to be 2 arguments. Is that normal?
Correct. It's always going to be 1 argument, self, for the getter, 2 arguments for the setter, self and something else. And the intuition for that is if you're getting a value, you don't need to pass anything else in because you already know the object. It's called student in this case, so you're just going to get the value of that property. But if you want to set the property to something else, you got to pass in that argument. You've got to pass in the value to which you want to set it. So it's always 0 or 1. However, you see it as 1 or 2 because, again, any function inside of a class, aka a method, is going to be automatically passed self so that you have access to that current object in memory. How about one other question on properties?
Why didn't we use the same underscore house in init method?
A good question. So even though I'm using the underscore house here in my setter and the underscore house here in my getter, I deliberately did not use it up here. The reason for that is that by using self.house and this equal sign, that's the same pattern that I want Python to recognize. I want Python to automatically call the setter even when I'm passing in the house via the init method. If I were to change this to do this, that would circumvent the setter, and now there's no error checking in init whatsoever. So it's such a fine line. The only thing standing between us and error checking or no error checking is the presence or absence of this underscore, but that's typically the convention. By not using the underscore there, make sure that even that assignment goes through the setter so that honestly I don't have to copy paste the same error checking in 2 places. I can put it just in the setter. So it's better designed, and that's why I manually retyped it at first, but then I deleted it from init. Well, allow me to propose that we make one other change to this file. Might as well go ahead and define a property for name as well. And let me go ahead and do this. Maybe above the house property, just to keep things in the same order as I defined them earlier. Let me give myself another property. This one's going to be called name. It's going to take one argument called self as always. And this one, very similarly, is just going to return self._name. So I'm going to anticipate that I'm going to have to rename name also so that I don't have that same collision as before. But now let me go ahead and define another setter, this one for name. So the convention is @name.setter. Why name? Because the property I just created is called name. So the getter and setter sort of work in conjunction in this way, if you will. Let me go down under @nameSetter and define another function also called name, but the key thing here is that it's not identical. It's not the exact same function name and the exact same number of arguments. The setter, again, takes a second argument, and I can call it anything I want, but I'm going to call it name because that's what's being passed in, and I'm going to put my error checking here. If not name, just like we used to do, let's go ahead and raise a value error, and let's put an explanatory message like missing name, quote unquote. Otherwise, let's go ahead and
Getters ve
update
setter arasında ana mantığını anlamış olmuş bulunuyorum.
And I don't have to change in it except to get rid of this duplicate error checking now.
Ya mantığını
because
hemen hemen
again,
anladım gibi.
if I use self.name equals here and self.house equals here with no underscore, both of those assignments are going to go through my two setter functions now.
Arkadaşım
Before we run this, let me
davet
go ahead
etti.
and
Okula
remove this
gideceğim.
adversarial code,
Burada
which we know
buluşacak
won't
kişi,
work
takılacak
because
kişi.
we're
Saat 1'de
catching it.
zaten toplantı
Let me go
vardı.
back down to my terminal window
Erkenden
and run
çıkayım.
Python of student.py
Şimdi bir
enter.
duş alayım.
Let's type in Harry, let's type in Gryffindor,
Sonra
and that seems
giyineyim,
to
gideyim.
work. Let's try though again to run Python of
Şu
student.py.
bitsin bakalım.
I can type anything. Why did we just go through all of that? Python, it's just the honor system. It's not baked into the language itself that there's a notion of visibility, public or private, or even somewhere in between protected. Instead, if you type private, that's even stopping you or me from circumventing all of these mechanisms, these properties, these getters and setters. We're ultimately just on the honor system not to do so when we see instance variables prefixed with one or perhaps even two underscores. All right, so this is a lot all at once, this introduction to object-oriented programming, but it might come as quite a surprise that even though we might have identified OOP by name in weeks past, we've all been using classes and objects for weeks now
Tamam.
in this
Şimdi
class.
bu kadar yeter o zaman. Kaç dakika oldu yayın açalı? 22 dakika olmuş. Güzel. 20 dakikadır. Şimdi çıkayım. Ben hazırlanıp çıkıyorum. Belki